In this video, we will be discussing who was at fault in the collision that took place on the corner of Ballarat Road and Hoadley Court. As you see in the forensic investigator sketch below, the Audi was travelling eastbound onto Ballarat Road going towards the city, which was occurring whilst the Mitsubishi was making a right turn from Hoadley Court onto Ballarat Road westbound. Both drivers seemed to have their different sides of the incident, starting off with the Audi claiming that the Mitsubishi appeared out of nowhere, which resulted in the Audi trying to suddenly brake. However, stopping in time wasn't achieved, which resulted in the collision. The Mitsubishi driver claimed that he was already awaiting in the intersection on a green light to make a right turn onto Ballarat Road, stating that the light had just turned red when the Audi smashed into him. Also that the Audi was exceeding the speed limit and jumping the green light. You can see from the illustration that the Audi suddenly braking caused skid marks with a length of 10 metres, resulting in continuous skid marks that were 3.5 metres long at an angle of 20 degrees below the horizontal. This incident included two vehicles, being a 2014 Audi A3 Sportsback and a 2014 Mitsubishi Outlander Aspire. The Audi had a curb weight of 1,220 kilograms, a passenger weight of 57 kilograms, and a fuel weight of 38 kilograms. This resulted in a total weight of being 1,316 kilograms. As for the Mitsubishi, its curb weight was 1,568 kilograms, a passenger weight of 55 kilograms, fuel weight of 43 kilograms, which calculated a total weight of 1,666 kilograms. This information then gives a total weight of both the vehicles being 2,982 kilograms.
In order to determine who was at fault in the collision, the initial velocities and final velocities of both cars were calculated. We were able to determine that the final velocity of the Audi was 6.98 meters per second. This is the same as the final velocity for the Mitsubishi, as they are joined in contact during the collision. This was determined by the rearrangement of the equation for work, which is also equal to the change in kinetic energy, which is 1/2 times mass times velocity squared. This value of 6.98 was then subbed into the equation to determine the initial velocities of both cars. We have taken the angle below the horizontal of the 3.5 meter skid marks to determine these values. Using the combined weight of the cars and the correct trigonometric function for the Audi, which is cos, and for the Mitsubishi, which is sine, we were able to display that the initial velocity of the Audi was 14.86 meters per second and the initial velocity of the Mitsubishi was 4.27 meters per second. In order to determine at what rate the two cars were moving after they collided, the conservation of momentum formula was rearranged to figure out that number. The momentum initial and momentum final had also had to be calculated in order to find this velocity. The momentum initial was calculated using the mass of the Audi multiplied by the velocity of the Audi, added with the mass of the Mitsubishi and the velocity of the Mitsubishi. This gave a total initial momentum of 26,669.58 kilograms meters per second. The final momentum was calculated using the total mass and the total velocity, which was equal to 2,982 for mass multiplied by the velocity in the final. In order to calculate this number, we then were able to rearrange the conservation of momentum equation to find velocity final. This was calculated using 26,669.58, which is equal to 2,982 multiplied by the velocity final divided by 2,982, which gave us a total of 8.94 meters per second, which means that the two cars collide at 8.94 meters per second. The next two slides discuss the velocity of the Audi after braking. In calculating the frictional force of the Audi, the first step for investigators was to determine the coefficient of friction. With the data that has been taken from the tyre test graph, which can be seen on the previous slide, the equation for friction was rearranged to determine the value of mu, which is 0.87. This tells us that there is a lot of friction present when the Audi is braking. From that, we are able to then determine from the mu value and the weight of the car being 1,316 kilograms and gravity, which is 9.8 meters per second, that the friction present at the time of the braking for the Audi was 11,186 newtons. The skid marks and the value of friction shows that the total work done by the Audi after the braking is 1,118,600 joules. In continuing to calculate the velocity of the Audi after braking, we are able to take our known values, which we have already calculated in previous slides, and sub them into the formula to calculate the velocity after braking. Our values for work, mu, 0.87, mass, 1,316 kilograms, gravity, 9.8 meters per second squared, and x, or distance covered, is 10 meters, which can be seen in previous slides on where the sketch is located. We also know that our initial velocity for the Audi is 14.86 meters per second. In subbing these values into our equation, as seen below, we are able to calculate that the velocity of the Audi after braking is 15.4 meters per second. The acceleration before impact was calculated for both the Audi and the Mitsubishi using the same formula, that acceleration is equal to velocity squared minus velocity initial squared divided by 2 multiplied by the distance. The distance travelled for the Audi was 10 meters, whereas the distance travelled for the Mitsubishi was 3.5 meters. Our velocity values and our velocity initial values have already been calculated in previous slides as discussed. The Audi can be seen to have decelerated before the impact of the collision with an acceleration of negative 8.61 meters per second squared, whereas the Mitsubishi had accelerated before the impact of the collision, with their acceleration being 4.36 meters per second squared. This shows that the Audi was trying to brake, whereas the Mitsubishi was trying to go faster in order to avoid the collision. As it was discussed earlier, the acceleration on impact was calculated using the A equals v squared minus v initial squared divided by 2 multiplied by the distance formula. It was found that the Audi had decelerated, with their acceleration being negative 8.61 meters per second. This is then converted into negative 31 kilometers per hour. However, the Mitsubishi had accelerated on impact, with their acceleration being 4.36 meters per second, or 15.7 kilometers per hour. Even though the Audi had decelerated at a rate of 31 kilometers per hour, the 53.5 kilometers per hour, which was a safe speed travelling through the 60 zone on Ballarat Road, was not enough to stop the collision from happening. As the Mitsubishi was travelling at 15.37 kilometers per hour, they collided on impact at 25 kilometers per hour, which is what has caused such a collision.
In conclusion, it has been gathered that the Mitsubishi was at fault due to it pulling out too late for the Audi to brake at the speed that it was travelling at. It's believed that the Audi was travelling at a safe speed of 53.5 km per hour in a 60 zone, then decelerated at 31 km, but it wasn't enough to avoid the collision with the Mitsubishi.